anymore. So anyway, Salim, thanks.
Thanks very much. I'm very pleased to have the opportunity to speak here. I'm going to be talking about something a friend and I have been working on since about 2004 called ILNP. And I'm going to kind of give you a what, why, how, and when of ILNP, what it is, and why it might be of interest to people. So what is it? ILNP stands for the Identifier Locator Network Protocol. Much more information, including papers and things, can be found at the URL there. And if you were to try and summarize ILNP in one sentence, it's really an enhancement to the Internet Protocol that tries to achieve a kind of harmonized functionality through the use of naming. So rather than add retrofit extra engineering extensions to IP, we're kind of trying to go back, look at the architecture and say, how can we change the way the naming is used? My colleague who's been working on this, Ran Atkinson, has over the last couple of years been discussing this within the IRTF, and in March early this year, the IRTF chairs recommended that an ITF work group is formed to see if this can be made workable. I'll explain what this is in a little while. It's still pretty much a work in progress. We have one overlay implementation, and hopefully in the next 18 months or so, I hope to have a kernel-based, or at least one kernel-based implementation of this. Although it's a new architectural approach I'm trying to describe to you, of course we need to build it, so we decided to retrofit the architectural ideas onto IPv6, and that's why I'll be talking later about ILNP v6, not because we had 5 versions that were rubbish and we had to throw them away, just because it's a retrofit onto IPv6. And in fact, some of these, we know these ideas are pretty good because they're not ours. Lots of people have had ideas along these lines, and I'll go through some of the rationale for ILNP and some of the background work as well. In fact, I'm going to do that now. So the intention with ILNP for Ran and I was really to look at the kind of new functionality people wanted from IP networks and think about how they could be provided in a harmonized way. So if we look at the list of things on that slide, multi-homing, mobility, multipath, transport, localized addressing, traffic engineering options, packet level security at the IP layer, all those things are available today. There are solutions for them, but they all require some sort of extension to be added to IP, and so when you try to put them together, the engineering landscape gets a little complex, and we were trying to see from a research point of view if it was possible to have something that was simpler than the current engineering landscape by going back to the architecture, but still give us all this functionality. So that was our starting point. However, one way we could have done this was to take a pretty clean slate approach and just say, okay, we'll just write it from scratch, a totally new network stack. But we thought another challenge that would be interesting for us was to see if we could make it backwards compatible and incrementally deployable. And after some thought and beer, we decided that really what we wanted to do was try and keep the core network from having to change too much, but accept that the end hosts may have to change. The stack on the end host may have to change in order to allow the changes we want and to enable the functionality we want in the way we want. So really this set of issues here, that the core network devices shouldn't change, reuse as much of the existing core as much as possible, are our 2 main issues that we wanted to retain. And then we realized that although we want to try and limit impact on existing applications, some of them might work, some of them may break, and certainly we will require the code on the end host to change. So, as I said, we're really looking at naming, and what is a name in the context of this talk? Well, it's any set of bits that you can attach to an object in the network stack, and really the semantics of that name are defined with respect to the object. And so here are some examples of what I would call names in this context. So a protocol name at the application layer, a port number, a fully qualified domain name, and in our context, an address is, the IP layer is also a name. It's a set of bits which can be used some way to label an object at the network layer. So one of the things that we looked at, and as I said, other people have looked at this before, is that the use of names in the internet, the internet protocols, the use of names is not very clean. There's an overloading of the semantics of, for example, especially the IP address, and that's what I'm going to be focusing on. So here's an example of a URL, and in fact the two URLs we have at the top, one with the fully qualified domain name and the IP address are equivalent. And so here the IP address is overloaded, and it might be used in an application like this as a session identifier. If we move down to the transport layer and we look at the transport layer state, if you look at how the endpoint is defined, of course you have both the local and remote IP addresses. All the bits in the local and remote IP address form part of the transport protocol state. And so here, the IP address is being used as an identifier for an endpoint of a transport layer connection. If we move down to the network layer, of course, the IP address is used at the network layer. Some of the bits are used in the core of the network prefix. Bits of it might be used for subnetting. And so in this case, it has some topological significance, and so it's being used as a locator in order to make the routing work in the core of the network. So again, we have a different semantic for the same set of bits. Locator at the network layer, identifier at the transport layer, and perhaps even used as a session identifier at the application layer. And then if you go down and look at the physical interfaces, so this is just a screenshot from my laptop. I'm not sure if you can see it very well, but here we have an interface. This happens to be a wireless interface, and the IP address is actually assigned to that physical interface. So in fact, the IP address bits are bound to an individual physical interface, not just the machine, but an interface of that machine. So this overloading of the IP address, the semantics of it, has been known actually for some time. People have said that this is probably a bad thing, and we probably want to try and get away from it. This is some text lifted straight out of RFC 4984, which is a report on a workshop that was in 2006. And it basically says that this locator identifier overload of the IP address is probably a bad thing, and we want to move away from that. But in fact, that wasn't the first time it was mentioned. If you go back about 10, oops, not back a slide, but forward a slide, but back 10 years, you find RFC 2101 from 1997. And that says a similar thing. It says that this overloading of the semantics of the IP address is probably going to be a bad thing, and we need to get away from it. And in fact, that wasn't the first time it was said. If you go back, again, not in the slide, but if you go back another 20 years, 1997, you have Internet Experimental Note 1. And I think you can Google for this and find a PDF somewhere on the network. And it doesn't use the same terminology we might use today, so it doesn't talk about mobility as such, and it doesn't talk about multi-homing as such, but it's clear what the intentions are. And it discusses physical versus logical addressing. And it says that if you conflate these semantics, you're going to have trouble when things are, when you have end systems that want to have a change in topology, i.e. mobility, or if they want to be multiply connected, i.e. they want to be multi-homed. So this is a problem that's been known about for a long time, and the problems identified in these documents and others we see are apparent today. There are problems with the overloading of the namespace. As a summary, this is what we have. If we look at the layers that I've just covered in these separate slides, we see that a lot of people have gone to the trouble of building this layered architecture and separating out the functionality, but then of course you use the same set of bits to label objects in the stack at different points in the stack, and you re-entangle the layers. So what this means in terms of functionality is, for example, if you were to use an IP address to identify an application level session, it means it's actually tied to the physical interface on that machine, because that's where the IP address is bound to. So if you want that application to be mobile, you want it to be multiply connected, you're going to have some problems. Of course, these problems aren't impossible to get around. We have solutions today for mobility. We have solutions today for multi-homing. But what happens is they each require some sort of extension set of entities to be deployed. For example, mobility requires a proxy system and a set of tunnels for it to work. And so we end up with a more complex engineering landscape, even though we can implement the functionality. Especially if we want to try and make some of this stuff work together, the engineering gets even more complex. So the intention with ILNP was to say we want all this functionality, but we want the engineering to be simpler. And we want to do that by having an architecture that's a little bit cleaner with respect to naming. So that was the rationale behind ILNP. So how have we gone about trying to address this problem? Well, this is the same table that I showed a couple of slides ago, and on the right we now have a summary of what ILNP tries to do. It tries to separate the layers, so disentangle them, by introducing a couple of new namespaces. So first of all, at the application layer, we try to encourage people to use fully qualified domain names only, and in fact this is in keeping with RFC 1958, which says that applications should normally just use FQDNs and shouldn't use addresses. And then at the transport layer, we have a new namespace which we're calling an identifier namespace, and at the IP address, at the IP layer, instead of having an address, we have something called a locator. Now the identifier has no topological significance at all. It's only there for identifying the end system. And the locator is topologically significant. Okay, that's the key difference that we have. So as I said, the way we chose to engineer it rather than go clean slate was to try and retrofit this onto IPv6. So ILNP v6 is what we're working on now, and this can be seen as a set of extensions to IPv6. And what we've tried to do is use the same packet format as IPv6, so the core routers and core network elements should not care. But it does mean that we do have an incremental deployment story for ILNP v6, and there is some level of backwards compatibility with IPv6. And how we've decided to massage ILNP into IPv6 is to take the 128-bit address space of IPv6 and only at the end host represent it in two 64-bit parts. So the upper 64 bits we call the locator, and that's a name for a network. And the lower 64 bits we're going to call an identifier, and that name's a node, not an interface, but a node. Okay. It is also possible to retrofit ILNP onto IPv4, and we have a kind of outline design for that, but things start to get a little messy on engineering. I'm not going to have time to cover that in the talk, but I'm very happy to take questions afterwards in breaks, etc. So this is the modification we're making to the IPv6 address. At the top of this slide is what is the format of the address as it exists today, straight from RFC 3587. And what we do in ILNP v6 is we take that same address structure and we now change it. So here, where we have the IPv6 prefix, we now call that the locator, but in ILNP that has the same syntax and semantics as for IPv6. So the same syntax and semantics, and because that should be the only part that the core routers look at, core routers should be happy that we haven't changed the syntax or the meaning of those bits. Then for the lower 64 bits, we retain the same syntax that's used for IP version 6, but we change the meaning, the semantics of the lower 64 bits. And we now say that the lower 64 bits is an identifier for a node, not for an interface on that node, but for the node itself. All right? So that's the key difference we've made. And what this does is it separates out the way that end systems identify endpoints for connections and for application level sessions, and the bits that are used in the core of the network for actually deciding which way a packet's going to go. So this, just for reference, is an IPv6 packet header. This is what the core of the network sees, but this is what's seen at the end system. So obviously the end systems have to be identified have to be modified to understand about the identifier, and know that the address space is split up into two separate parts. A little bit more about locators and identifiers. The locator is topologically significant, and it takes the same syntax and semantics as today's network prefix for IP version 6. But the identifier has nothing to do with routing at all. It is only used on the end systems, and it is not topologically significant. And the key difference between V6, IPv6 and ILNP v6 is that end systems do not bind to the full 128 bits. They only bind to this 64 bits of the identifier. Now, because that's got nothing to do with the way the packets ship through the network, you can have dynamic bindings, you can have multiple identifiers binding to multiple locators, you can have one identifier binding to multiple locators at the same time, so you get multi-homing. You can have the locator value change on the fly, i.e. mobility, but the identifier that's bound to an endpoint connection doesn't change, so you maintain the integrity of the end-to-end connection. Okay, so we're trying to separate out the layers, so a change at one layer doesn't impact the layers higher up. In fact, this slide pretty much says what I've just said about the two values. During a particular session, a locator value can change, and you can have multiple locators. For a given transport layer session, the identifier has to remain fixed. Now, in fact, a node can use multiple identifiers simultaneously, but for a given transport layer session, whatever identifier it uses to start that transport connection, that must remain fixed throughout the lifetime of that connection. So, this is how we're going to implement our various functions. Unfortunately, I don't have time to go through how all the functions are implemented, but I'm very happy to answer questions on those. There is a no free lunch clause on ILNP, and the no free lunch clause on ILNP is we make more use of DNS. Because now we're moving to a system whereby names are more important, somehow when you have a fully qualified domain name and you want to contact a host that uses ILNP v6, you have to know its current set of locator values and identifier values, and so that means putting them in the DNS, that when you do a name lookup, you get back a set of identifiers and locators that are currently valid for that node. Development of ILNP, where are we up to? Well, there were a bunch of options that we had. Simulation was an option, but we realized the amount of code we'd have to write, we may as well just try and build it. We have an emulation that's been done as an overlay, and I had a master's student do that in 2009, and that demonstrated mobility and multi-homing working together quite nicely, with a few constraints. It's constrained to a single lab. It wouldn't work in the wide area. We also looked at possibly running it over infrastructures like Planet Lab and OneLab, but because we need to make changes to the way that the addressing works, we thought it was going to be too hard. So really, what we're working on is an implementation in an OS stack. We're working on both a Linux port and a FreeBSD port, and hopefully we get those done sometime next year and we start giving them away for free. As I said, ILNP v6 is much more reliant on DNS. In fact, it could be argued it's no more reliant on DNS than applications and systems are today. It's just in ILNP we make it quite explicit. There's also an interesting feature for ILNP, which is in order to support mobility and work with the DNS, you need to turn down, in fact turn off the caching for some of the locator records. So you've got to have 0 TTL for some DNS records. Now this sounds a little bit scary in some cases, but in fact I have some numbers on this. We actually ran 0 TTL on an operational DNS installation at my institute, and we did it in fact 3 times over 3 years, and each time, you know, we lived, nothing really bad happened. I have some numbers on that if people are interested. With ILNP v6, renumbering and address management at sites is still an issue. It's no better, but no worse than it would be for IPv6. And then some other things happen which may not make some applications happy. For example, because we no longer have a globally routable name, an IP address tied to an interface, some applications like SNMP might break. And some legacy applications that ship addresses in application space, like FTP, they'll probably need some sort of gateway mechanism. And the other thing we haven't thought about very much are interworking scenarios. What happens when you want to interwork ILNP v6 with IPv6 or IPv4? Now, I've been asked just to make a comparison of ILNP with Lisp, because Lisp, of course, also has the words locator and identifier somewhere in the acronym. But in fact, the two things are very different beasts. Lisp is really coming at a very specific problem, well, it was initially, as far as I understand, to solve the problem of growth in the core routing tables for the internet and try and remove some of the state that's kept in the core. And ILNP v6 is really something that Ran and I are tinkering with because we had some research questions we wanted to investigate. Nevertheless, it is possible to make a comparison of them, and in fact it shows that they're quite different. In Lisp, what changes is the network, so new network entities are required for mapping of end system identifiers and routing locators, whereas in ILNP v6 only the end host changes. Site renumbering is not required at all for Lisp, but is optional for ILNP v6, and of course ILNP v6 requires end host to change, which of course may not be acceptable to some customers. There are a whole bunch of other issues where the two differ. I don't think I'm going to have time to cover all of them because I've got to leave some time for questions. One main difference is that there is working code for Lisp. It's out there today and you can use it. And for ILNP v6, it's still pretty much a work in progress, but we hope to have something available in just over a year's time. Also, Lisp works with v6 and v4. And although here I say ILNP will work with v4, I suspect the answer really is no. It requires an IPv4 extension header, which for most people means it's not going to get through the core network. So it's technically possible, but probably not deployable. There are a bunch of other things that, of course, we were designing ILNP v6 for, so we think it does do them, and in fact Lisp is now starting to address some of those functionality issues as well. Right, so that's all I wanted to say about ILNP, try to introduce you to this idea of changing the way that naming is used, and I hope I've left about 5 minutes for questions. Thank you very much.
Kevin Orman, ESNet. This isn't really a question, just a congratulations. I believe this is the first talk we've had at NANOG on extensions and work on improving IPv6 rather than just getting it implemented and up and running. And I'm delighted to hear that we're now looking, somebody is starting to look beyond just doing IPv6. Not that I'm suggesting any of those who are not running IPv6 stop working on that.
Michael Sinatra over on the side here. Michael Sinatra, UC Berkeley. I'm interested in what your thoughts are on what the best practices will be for numbering your, or how you will handle your authoritative DNS server in an ILNP world, because you're going to have to, somehow you're going to have to get to that authoritative DNS server, and will you have L64 records in as glue records in your parent? And if so, how will you update them when the prefixes change because you're changing providers or because you are, one of your links goes down?
Right, so I think the question was that what are the dynamics of changing locator values? Have I paraphrased that correctly?
Yes, but specifically how you handle that with the authoritative DNS servers, which are the ones presumably which have the information about the changing locator values.
Right.
There's sort of a chicken and egg thing there.
Right, so again, yes, this talk was very quick, but we have to assume that you have DNSSEC running, and that when you do make updates, you know your authoritative DNS server you can check its authenticity and then make the change.
My question was sort of focused on the other side, whereas I have a service running like a web server
Right.
that is on an ILNP enabled network. One of my prefixes goes down.
Right.
How do other people know now when they do a DNS lookup, they're going to have to say, okay, I've dropped a prefix here, but they're going to have to get to that DNS server that's going to tell them that information.
Right, okay, so let's assume you already know what your prefixes are. There's a different story if you don't know your prefixes, but let's assume you know what your prefixes are. Both of those can remain in DNS together, and there are some preference bits to indicate which one should be tried first. And if that one doesn't work, you then try the next one at the application level.
Thanks.
So Danny McPherson, I had two comments. One was actually somewhat related to that question, which is basically just protocol architecture stuff and the notion of circular dependencies and routing relying on DNS to work and DNS relying on routing to work. And that becomes problematic in large distributed systems, I think. That was sort of one of the points. I actually wanted to ask of you if you would post the data that you said you had on TTLs, basically no caching and what the implications that were on in that environment that you tested that 3 times. That would be very useful. I would appreciate it. So if you could post that to NANOG maybe or something.
Right, I'm very happy to show you the graphs, but I'm afraid I'm not permitted to share the data much as I'd like to. So it was collected under the Data Protection Act, which exists in the UK, and the agreement we have says that we're not allowed to share the data, which I'm unhappy about as well, but that's the way, unfortunately, it works. Because, for example, I'd like to just give out sanitized TCP dumps, but because they may lead to violation of individuals' privacy, under UK law, that's not permitted.
I wasn't looking for the details, just sort of the macro analytical. Otherwise, you and I have a circular dependency where you're referencing data that we can't actually see, so we can't rely on the data to believe what you're saying. So,
Right.
So anyway, yeah, if you could provide a high-level summary of the findings, that would be very useful.
Okay, yep.
Thank you.
Dave Meyer. So I wanted to get your opinion on one thing. So we have all this. You kind of showed us all of this wisdom that had come down from the stratosphere through the internet history and Noel and all of these guys. And there's the assumption that locator ID split is the way to scale routing and do a bunch of other things like mobility and stuff like that. But what we're seeing right now is it's actually getting built. And so we're getting some pragmatic experience with things like Lisp and ILNP and other kind of approaches to this whole thing. And I don't know if you've looked at the stuff I've written on locator ID split and what it means for an architecture, but it introduces some other kind of really hard problems. And in particular, and I will say that the designers, the people like Noel and these folks who really cooked this up, or who realized the overloading and all of this stuff, never really got to the point where they were implementing it. So some of the problems that become apparent when you try to deploy this stuff weren't apparent to them. And I'll just give you one example, and I just want to get your opinion on this kind of stuff. Basically, if you do locator ID split, then you have to maintain the binding between the locator and the ID. And you're doing it with DNS, and Lisp does it with the mapping system stuff. The problem with that is that problem is inherently n squared. And if you look at something like the REAP protocol inside Shim6, that's basically n squared problem with a bunch of heuristics to try to avoid that scaling property, right? So now what you've done is you're trying to introduce some kind of robustness into the system with all of this stuff, but you created a fragility. And the question is, how bad is that fragility?
Right.
And this is kind of like a dynamic systems question about, or complex systems question about robustness complexity trade-offs, but that one has not been well studied. I wrote about it twice. I think you've seen the stuff I wrote about it, but I'm not convinced quite yet, because of this exact issue. So I just wanted to hear your comments on that.
So I think, is this the rate time state, or rate time state is part of the issue in terms of updates?
The rate time state thing was the Tony Lee formulation of the problem with the routing system.
Right.
This is a different thing. I have a binding between locator and identifier.
Right.
How do I know that locator that's bound to the identifier is any good?
Right. So there are two situations you want to look at that. Once when you're setting up a session, and that's when you would take a fully qualified domain name as you do now, look it up, and you would get back locator and identifier records from the DNS.
Yeah, the mapping system can work, but
Right.
that doesn't tell you anything. See, that doesn't tell you about the reachability of that locator. So the
True.
locator itself might be dead, and there might be
Right.
N quad A records for it.
Right.
You know,
Right. But maybe I haven't understood the question, but is that any different from what we have today when you look up an address and you don't know if it's reachable?
yeah, it's different because the signaling that the host gets
Right.
will be like, I send a SYN and I don't ever get a SYNAC, right? Now I can just bump down the DNS
Right.
and get the next day record if there is one, and if there
Right.
isn't one, the thing failed.
Right.
If it's loc ID split and the locator ID mapping isn't visible to the host, it can't do that. So things like GSE had this problem. Things like 8+8 and GSE had this problem. Things like Lisp have this problem, where we depend heavily on the fact that the SYNAC is signaling liveness of the locator. We just didn't think about it that way when we were designing it.
Right. So.
And then the host can take action. In the locator ID split case, the host can't take action.
Right. So I think there is a pathological case which is an example. So for example, you have a client system, it's talking to an end system using ILNP, it looks up the locator value, sends the SYN, and between the SYN getting to the remote host moves, and the SYNAC coming back, the remote host moves. So its locator has changed because it's moved, for example, and so there's no way to finish the TCP handshake and set up that connection, right? Is that the kind of situation you're describing?
And worse, there's an external database that's not giving notification to the people who have queried that database for information that it's changed.
So that kind of case is exactly the kind of thing we're looking at, and I totally agree with you. That's going to be the kind of thing that like governs whether this is going to be deployable and usable in various scenarios. And the first part of that has been looking at what's the behavior of DNS when you have very low TTLs for some of the DNS records, and so you expect them only to be live for that lookup, and then you expect a host to move. Now, we haven't progressed to the point where we're testing real application behavior over a real network with that, but we're trying to gauge the dynamics of some of the infrastructure that could support that. So we're not very far progressed along that at the moment. Okay, thank you.
Okay, thanks very much, Celine.